Okay, so here we have the finished product right here. So, show it off a bit. It's the front. You know, it's not, not pretty, but, prettier than some things that I've made. Let's see here. Turn it off for now. Yeah, just to get a good shot there. Okay. So, here we go. Show it off a bit. So, we can turn it on. Let's see here, and I gotta play with the camera a bit. Okay, so yeah, we can turn it on. It's got the fan running, so we can hear the fan. And I have it all turned down right now, so I'll turn this one up to about midpoint there. That's my fine adjustment. That's my coarse adjustment. That's my power switch for, the ammeter, the fan, the whole 9 yards. And then this is my switch for my loop. So let's go ahead and turn on my power supply. My power supply right now is set for a 1/2 amp. And I'm going to go ahead and show you what I can do with my whole contraption here. So, turn on my test loop there and start turning this up. And let's go ahead and set it for like a 1/4 amp. 1/4 amp right now. It takes a little bit of fiddling. There we go, 2.6. Turn it down to 2.5. Fine. There we go. So, as we can see, we have a 1/4 amp here on my dummy load and a 1/4 amp at 6 volts here on my power supply. And so, just to show off here, go up to 1/3 amp. 1, 2, 3, hey, there we go. And yeah, so 1/3 amp here, 1/3 amp here, 1/3 amp there. How about that? And that fan is doing a fairly decent job of pushing air through the whole thing. The air that's coming out is still, it's still cool. So, it's not really an indicator of what the, the temperature inside is. But as long as I'm not a retard, it should be all right. If I'm gonna, I'm not gonna want to push, 10 or 15 amps through this thing, obviously. If I was really, really smart, I would have put a fuse in here. It's possible that I could, really crank it up and, potentially melt something inside. But, that's, you got to use some judgment with that. That's your only solution. If it turns out something is getting warm, well, then turn the damn thing off. And it is, now the adjustment on it is a little touchy. Let's see here. Right now that's saying it's at a 1/4 amp, and over there it's saying, 2.4. So a little measurement error. But also on the power supply, it'll occasionally, switch around from 2.4 to 2.5. So still, I'd call that accurate. That tends to be something that, I've noticed happens, right now is a good, happens right on edge cases. But I think that's just, something with the digital stuff. Digital anything only has so much accuracy. So yeah, I'm really happy with this. Started out, about controlling a fan and using hysteresis with an op amp. That was the original idea, and we got rid of that, so, now it's just, fans constantly on, but that's fine. And I'm really happy with how this whole thing turned out. there are, the circuit is simple enough to where it's, you can really adapt it for a lot of things. I've seen people do this with, where they've had data logging on it, where they could hook it up to a computer and, fetch and, retrieve, log information about a load so they could judge the discharge characteristics of a battery. I'm mainly going to be measuring the outputs of little power converters like this, just to make sure that the power converter can output what it says it's rated to output. So this little box that I have now is going to do a decent job of that. And I really like having these terminals on here because it means that I'm going to have a nice easy time connecting things, because I don't need to use actually the gator clips to connect to this. Grab the grab the leads off the power supply there, and I can just plug them straight in here like so. And now I can connect the gator clips up to something like this here. See how this is doing. Or conceivably I could get some other kind of connector. So, hey, really happy with how this all turned out. Can't complain. And I'm going to have to upload a bunch of videos to YouTube.